If you grew up with 8-bit consoles, then this is probably quite a familiar scene. As a game gets more and more chaotic, enemies, shots, and even the player character seem to flicker in and out of existence. Some games you might not even notice, others become borderline unplayable, and some don't even seem to flicker at all. A particular oddity that always fascinated me was how on certain frames in Mega Man 2, the entirety of Mega Man's face seems to vanish into thin air. So, what's going on here? As a kid, I always thought that flicker was just the default, the console being pushed to the extreme, giving its all to draw everything to the screen in time and failing, but it turns out that's only half true. I didn't fully realize just how much the programmer needs to deal with sprite priority until I had to start implementing it myself while developing my Sega Master System game, Space Tombo. Download link in the description. In order to figure out what's going on, we need to stop thinking like the player and start thinking like the game console. More specifically, the video display processor. For example, this is not Mega Man. This is just 10 sprites drawn in close proximity, and we're already starting to run into trouble. This is because any given 8-bit system has certain limits when it comes to rendering sprites to the screen. One such limit is the number of possible sprites that can be drawn on a single horizontal line. In the case of the NES and Master System, that magic number is 8 sprites per scan line. So, for a game like Mega Man 2 on the NES, where the entirety of the game takes place horizontally, you can see how we can run into this issue pretty quickly. Mega Man is already 5 sprites wide when firing. Throw in a boss and some projectiles and that 8 sprite limit gets hit mighty quick. An even more extreme example would be the Master System version of R-Type, where you can't even fire without your ship dipping into the void, and when the game starts pulling out all the stops, well, you can forget about being able to see what you're shooting at. So, let's investigate by getting our hands dirty with some assembly code of our own. Here, we've got a ROM I made for the Master System that showcases exactly what happens when we max out the horizontal sprite limit. We start off with a full row of 8 sprites on a single horizontal line, and when we introduce a 9th sprite, yeah, that's not flicker. The 9th sprite got eaten. To be more accurate, it didn't even get rendered once it crossed over the 8 sprite event horizon. Again, we need to think like the game console in order to understand what's going on here. Inside the visual display processor of the SMS lives the Sprite Attribute Table, or SAT, which contains all of the data related to each sprite rendered on the screen. The order in which sprites are written to the SAT determines the order in which they're drawn. This means that it doesn't matter if our 9th sprite in the SAT is physically to the right or left of any other sprites when it comes to rendering it on the screen. The only thing that matters is where it falls in the sprite attribute table in relation to the other sprites on the same horizontal line. Believe it or not, this side effect of sprite overload was actually put to use intentionally in some cases. Say what you like about Castlevania 2 Simon's Quest, but it's got what I think is one of the most clever uses of making the hardware limits work for you. Did you notice in our demo how smoothly the 9th sprite disappears? 1 pixel at a time. In Simon's Quest, this is abused whenever Simon jumps into the mud pools. Instead of having to animate Simon's legs disappearing, the developers just threw 8 invisible sprites with high priority on the same horizontal line as the mud, causing Simon to smoothly fall in up to his waist. It's such a simple yet creative way to get a smooth sprite transition. But this still isn't sprite flicker, so what's missing? Let's go back to our SMS demo and try shuffling the order of the SAT and put the 2nd sprite as the final entry. Now, when our 9th sprite crosses the 8th sprite event horizon again, this time the 2nd sprite is the one to disappear instead. Wait, we can work with this. If we shuffle the order of the table on every frame, then each time a new frame is drawn, a different sprite will be lost, and at 60 frames per second, bam! We get that signature flicker effect. This is the exact implementation used on the NES as well. In the case of Mega Man 2, Mega Man's face is made from a different sprite than the rest of his head. This is because his face uses a separate sprite palette than the rest of his body to give him his skin and eye colors. This also means that on certain frames, Mega Man's face is the sprite that gets dropped. It can be a little uncanny for sure, but when we compare it to something like R-Type on the Master System, well, they really just said to hell with sprite limits and threw everything they had at the screen to let it be sorted out by flicker. Readability be damned. It's ambitious and I can respect that, but there's no doubt that it can definitely overstay its welcome. This likely would have been the case for the Master System port of Golden Axe if Sega hadn't found a way to circumvent sprite limits altogether by eschewing sprites entirely. That's right, Golden Axe renders all of its characters as part of the background. It uses a complex screen blitting technique where the characters are drawn on top of the background graphics on the fly as they move around. Granted, this forces the characters to move in 8x8 pixel chunks at a time, which means the movement doesn't feel quite as smooth as other games on the SMS that use sprites. When you're actually playing though, it's hardly noticeable, and it's a clever way to get around the Master System's sprite limitations while still having huge detailed characters on the screen. If there's one thing I want you to take away from this video, it's that when it comes to 8-bit programming, nothing is done by accident. Assembly and 8-bit hardware are my passions, so leave a comment about any 8-bit programming or graphics effects questions you have and I'll try to answer them in a future video. If you'd like to support not only the channel, but also the development of new 8-bit titles like Space Tombo and Project SMS 1000, consider supporting me on Patreon. I'm Bofner and thanks for watching. See ya!